Welcome back from the break. Up next, we have Hananiel talking about Steeltoe, a framework I love, close to my heart. So tune in for that, and we're ready for you to welcome you, Hananiel. Take it away.
Awesome. Hey, thanks. And welcome everybody to the session called You Can Be Cloud Native Too. I'm Hananiel Sarella. A little bit about myself. I've been a software engineer developer for a little over 20 years now. And I've worked with companies big and small, some of them in the Fortune 100, so large enterprises. So I switched stacks a couple of times between Java and .NET. So that made me a great place here at Steeltoe with VMware, actually. So it's a really exciting place, lots of knowledgeable people, and we're required to stay on top of things. So if that sounds exciting to you, I have some great news. We are hiring, so please reach out. There's some contact information later on. So let's get stuck in and dive into this presentation. And first, I'll start off with this disclaimer. It's basically legalese that tells you that some of the things we're talking about are in no obligation, or there's no legal obligation to actually make that available. So it does not represent a contract. So let's dive into what is cloud native and get level set here. And I think one of the most succinct explanations or statements on this comes from the famous Joe Beda, of course, co-founder of Kubernetes and principal engineer at VMware. So cloud native, as you can see, is about structuring teams, culture, and technology, and utilizing automation. But at the end of the day, no matter what you're doing in which environment you're delivering code, usually in an enterprise or for some sort of business, you are delivering business value. So everything else ends up becoming what's called undifferentiated yak shaving. So the essentials of these things are you as a developer producing actual business value for your customers. So how does one become cloud native? So there's a plethora of things. So obviously, it's not just about code and architecture. There's a whole slew of things that you need to get good at and leverage. But for the purpose of this talk, we're going to focus on microservices or microservice-based architecture, which is an architectural approach to developing applications for the cloud. And so what do we mean by that? So again, when we're talking about microservice, we usually contrast it with something that's a monolith. Back in the day when I first started, we were deploying, installing software directly on servers and deploying our applications there. And depending on the size of the team, if these things got really big, it took months to deploy change into production. From there, we kind of discovered that breaking these things into small independent services with a well-defined API and giving each microservice team ownership of its own data helps you deliver software faster into production. So that's the benefits of this. And typically these communicate via REST or some other inter-process communication methodology. So as great are as the advantages are for microservices, that obviously comes with a number of difficulties as well. It is no doubt clearly enabling for teams to be able to be so much more productive and bring value faster to market. But now we have a whole set of other problems. For example, how are you going to, when you scale applications up and down response to demand, keep track of where things are? And the interactions between these services are also more difficult to achieve and also to test. And requests that are involve multiple services become so much more difficult to troubleshoot in production. And so there's a whole set of problems that come with adopting a microservice-based architecture. And not only just any cloud and any microservice environment. So if you go to what an ideal world should be. So recently, VMware conducted a survey of their customers of what they expect in a cloud environment. And these 4 points stood out the most. One is people want consistent management, regardless of where the applications were deployed, whether on premise or in the cloud. people want to manage it in a consistent way. You want to be able to run these and build these anywhere using the same methods. And of course, no matter where they run, you want them to be secure. And oftentimes business pushes new environments at you because of acquisitions or some other environmental changes, and your code and architecture need to adapt to that. So how can we solve these problems, and how can we achieve this ideal world? Now, to put another kink in this, we've talked about on-premise and cloud and managed cloud, but recently Gartner did a survey where they found that 81% of the people participating in the survey were in 2 or more public cloud environments. And they have a prediction that 75% in the future will run in a multi-cloud. So now you have this problem of not only targeting a cloud, now you've kind of come across this application modernization path of taking your monolithic practices and adopting to a microservice-based world. But now all of a sudden, you have more and more dependency on a specific cloud provider. So in this world of multi-cloud, you need to build things in such a way that you can move across them without making code changes. So right off the bat, as far as just having microservice-based applications or distributed systems, you have the problems of achieving scalability, security, observability, and ease of use for teams adopting these practices quickly. And for achieving a multi-cloud ideal happy state, you also, in our view from the Steeltoe team, need to build on abstractions and also build on open source software. By that we mean don't blindly adopt whatever your cloud service provider might be throwing at you, but build on well-established patterns. Some of these things are very new, but some of these patterns have also been around for a long time and are being quickly adopted for a multi-cloud world. So that brings us right into our the project that I'm going to talk about, in whose context we're talking about microservices, which is a Steeltoe project. It's an open source project that started about 5 years ago. And so it's not new, it's been around for a while, lots of contributions to it and lots of NuGet downloads. Somewhere around 2018, it was donated to the .NET Foundation. And currently it supports all of the available .NET flavors of .NET Framework, Core, and .NET 5. And pretty soon we're going to add support for .NET 6. And there's a lot of documentation and samples to help you get started. And there's lots of help available on the Slack channel, on the open Steeltoe Slack channel, that you can anytime reach out and ask questions from, and somebody from the development team is there to help you. So what are we focused on building? And the primary thing that we're focused on building is making your microservices, building production-grade cloud-native microservices. And by that, we mean simplifying some of the problems that we talked about so far, right? And also, we have a strong focus on building on top of abstractions so that you're not tied to any particular cloud platform. And when needed, it's easy for you to implement these abstractions yourself or come together as an open source community to build them together. We also have a vision to have out-of-the-box integration between Java Spring and .NET microservices. And some of these patterns are well tested in the Spring world, have years of experience and lots of customers using them in the enterprise. And now we're making those well-established patterns available for .NET developers. And for those teams that use both Java and .NET, it's a huge win. And our fourth focus is obviously to provide developer productivity tools to quickly set up things and target whether it's your laptop or a bare metal server or a managed cloud platform. So tooling to make all these things possible. So what does Steeltoe framework provide so far? It provides quite a few things. Broad classes of these are scalability. How do you scale your microservice application easily? How do you keep them resilient? How do you make sure they're observable, easy to debug problems in production? And some providers to make things secure. And the last one that we recently added with 3.1 release of Steeltoe is messaging and stream processing, which enables a whole new class of microservices. So let's dive into a few of these quickly. So first up is problem of service discovery. By that we mean, so you had this monolith and all of the components of the monolith were in one place. It was easy to find for one subsystem to find another system since it was in the exact same code base and exact same environment. So now with the microservices architecture, now you're talking across multiple servers sometimes and multiple nodes. And so each of these service instances are being scaled up and down in response to the business environment. So the problem is, how does a service client find its upstream? And so there's a simple solution to this. It's called a service registry pattern. And typically you have a registry client that registers each of these instances as they come up to a service registry. And then the service client is able to query the service registry to get information about its upstreams. So that's pretty straightforward, but it's also not something that you want to implement yourself. So what does Steeltoe provide? Today, we provide a Eureka integration with Eureka through the Steeltoe Discovery Client and HashiCorp console. So, and also for Kubernetes. Now, the thing about it is it makes it so easy to integrate with these things by not actually getting a direct dependency on these, but you take a dependency on Steeltoe and you add the appropriate NuGet from Eureka or console. And depending on which one you added, without changing a line in your code, you're able to deploy. And not only that, when you come to Kubernetes, you may be aware that it natively has DNS-based service discovery, so you don't need something specifically. But our vision is to take this exact same code base and deploy it in multiple places. And in order to do that, by taking on, adding a single line of code, which you'll see in a second here, you can deploy to any of these environments and not have the code be aware of that and make and rebuild and compile your changes. So in addition to that, you also have help with having client-side load balancing through the Discovery client. And today we have the option of a random load balancer or a round-robin load balancer. And so that helps even if you're in Kubernetes. Now, we kind of talked about this. Does it mean now that since you're taking on a dependency on Steeltoe, that the Steeltoe code is strewn all over your code base? No, in fact, these things are built in a way to be very user-friendly and also as easy as it is to add something like this. It's just, you can see just one line here in the program.cs file, which is your main class, and you have your generic host being built. You just use this extension method to add one line, and it adds things to your service container, activates them, and makes sure the right behavior and functionality gets enabled in your app. And if for whatever reason you don't like this, it's as easy, obviously, to remove it. And now with some new changes in Steeltoe, we've made this even easier. So let's keep going. Another thing I talked about was building on top of abstractions. Now you can imagine there's a new service discovery server or a solution that's available. And by using things like abstractions, a well-defined notion of a registry, you can plug in, replace any of these much more easily. We achieve decoupling from the implementation details through interfaces. So that's a key building block of using Steeltoe. We provide well-designed default implementations of many of these abstractions. And if for any reason you need to change them, they are public and available to override in your own code. And not only that, but being an open source project, you're always welcome to provide a PR and suggest a change. And we've got a number of changes like that to our code base. So that's what's, again, exciting about being in the open source world. So let's keep going. Here, another facility that Steeltoe adds is easy configuration. One of the problems in the microservice world is how do you push configuration from a centralized place into multiple microservices. Here we have a config server provider, which integrates with Spring Cloud Config Server and makes this possible for configuration to be pushed to different application, different instances, for example. And then we have other helper providers, such as the random or placeholder provider that makes it easy to manage configuration. And of course, we have support for Cloud Foundry. And not only that, we also have one for Kubernetes to make your config maps available. So let's keep moving along. And here's, again, a code sample of what this would look like in your code base. You simply add one line, and bingo, everything is available for you to use. So next up, another problem with distributed systems is fault tolerance, right? So what we mean by that is if you have your monolith broken up into multiple components, you don't want one service to take down the entire application. So you can easily imagine, let's say, a catalog service that's loading up your catalog information from a database, and maybe you have a issue with the database or the connectivity there, and all of a sudden you have thousands of customers clicking on your front-end app trying to load the catalog. But because it's down, you'll quickly overwhelm the front-end resources, and maybe you have autoscalers set up to load on increase the instance count on when they see a lot of load, and you'll quickly run out of resources in your cloud environment. So to prevent something like this, we have the circuit breaker pattern, and where something is observing the state of these circuits, if you will, and if they notice a problem like 10 connections have failed or 100 connections have failed, you quickly close the circuit and provide an intelligent default. Maybe you have a limited set of catalog or a limited set of products that you serve up. And so, yes, your customer will be seeing a degraded performance, but it will not be a catastrophic failure. Now, implementing things like this is complex in that now there's a lot of variability, and when things aren't exactly functioning right, you need to have a good visibility into what exactly is happening in these systems. And so for that, we have the metrics dashboard. Of course, the Steeltoe circuit breaker is built on top of the Netflix Hystrix library, or it's an implementation of Netflix Hystrix. And it supports the exact same dashboard that Hystrix provides. And if you're in a cloud environment that has support for these dashboards, that makes it very easy. Or you can spin up your own. So we are not tied to any particular cloud, although we have better support for some of them. So let's keep moving along. And another key aspect, like I was mentioning about observability in the context of circuits, also general observability and manageability of these instances. And here we have obviously management endpoints. And if you're coming from the Spring Boot world, you may know them as actuators. And we provide many of these similar things. And notable among them is the endpoints that we use for observability, which are the three pillars of observability. We have logging, tracing, and metrics. So we have endpoints, for example, to scale up or down the verbosity of your log level at runtime. So because you have thousands of applications and many multiple instances of these applications running, you need a way to change the verbosity rather than pushing a configuration to each instance. That's just not sustainable. So we have tooling to be able to do that, where when you're troubleshooting a problem from a console, you can dynamically at runtime by namespace increase or lower the level of logging so they can quickly troubleshoot what the problems are. Not only that, you need ability to trace messages or traffic as it comes along between these various components. So we have integration with things like Zipkin to be able to view your log traces that are going across and visualize application maps and so forth. And of course, we have metrics integration with things like Wavefront from VMware, or any metrics solution that you can think of, presumably, because most of them implement Prometheus, and we have the ability to export metrics, whether it's CLR level metrics or others, via these endpoints. So it gives you a great deal of control over your applications running in the cloud. And also the specific viewpoint and specific way we do things, we are friendly to the Spring Boot way of doing things. So that allows us to do things like this. So here we have Azure Spring Cloud, which is a partnership between VMware and Microsoft to support Spring Boot apps. And now today we have the ability to deploy Steeltoe apps, which is available as a public preview. So now you have Steeltoe apps and Java apps working happily in this environment. So that's a huge win for enterprises that use both technologies, or even just people using Steeltoe and .NET apps by itself to be able to do things this way. Finally, we have a support for ease of use. There's numerous connectors that help you get started talking to various databases. And Steeltoe Initializer is another great example of where you can have teams quickly start up with sensible defaults for your enterprise and customize Initializer and help teams spin up microservices quickly. And as far as ease of use, we've kind of seen how easy it was already to add Steeltoe and components to your application. Now we made it even easier with this overall add Steeltoe extension method that, depending on the packages and NuGets that are available, does the right thing for you. It becomes super simple to adopt. And of course, if you want to get off Steeltoe, it becomes easy to do that as well, since your contract with Steeltoe is not smeared all through your application. So that brings me to the latest addition or latest major improvement or contribution to Steeltoe, which is the ability to support a new class of applications that communicate via asynchronously. So far, the things we talked about are focused on synchronous, and now we have support for things like messaging and streams. So basically, we bring a flexible programming model, a higher level programming model for building event-driven and stream-based applications. So messaging helps you talk through a well-defined constructs to various messaging brokers. For example, RabbitMQ, which is what we have right now. Pretty soon we'll have support for Kafka. And same thing with stream. Now, what that allows you to do is ability to communicate with the Spring counterparts. Now, you can imagine a Steeltoe microservice talking via one of these brokers in your enterprise with Java, a microservice, and supporting the same sort of constructs and similar ways to manage these things. And again, it is very easy to adopt this. Here's an example of a streams application, and you have 3 simple steps. You have a custom host that we've built to support the runtime components of this long-running application. We have some annotations that helps you set this up, in this case, as a processor, for example. And Steeltoe does everything else for you, creating queues or topics on the broker and making it very easy to communicate. So that brings us integration with things like Spring Cloud Data Flow. Now we have support for Steeltoe applications There's a lot we can talk about it there, but the best way is to go to dataflow.spring.io and get started. But now all of a sudden, all those Java applications are available for use for a .NET developer. Here's an example of it running in the cloud, interacting between Java and .NET apps. So what we have here, I've kind of shown how easy it is to adopt cloud native microservices approach to building applications for .NET teams, and also being polyglot, because one of the things that developers want to do is be able to pick and choose the technology stack they want. And when you have guardrails and good patterns implemented around this, this becomes so easy. So I hope you're as excited as we are about this. And if you have questions, please join us here, and we'll shortly be available in another chat room to be able to ask questions if you're interested. So that's it. Thank you for paying attention. Thank you for listening. And thank you for the Spring organizers for having me here. There we go.
Hi, Hananiel. Thank you so much for such a great presentation. I love Steeltoe. I love hearing about Steeltoe and Spring working together. To continue the conversation with Hananiel, please go to the Q&A session, which you can find the link in the Slack to the discussion. You can click on that. It'll open up the Slack, and you can click into the link. Up next, we have driving the data pipelines for connected vehicles with Spring and Cloud Data with Spring Cloud Data Flow. With Banu from WePro. Please join us at 3:35, and we'll see you then. In the meantime, you're welcome to be in the Q&A or take a short break. Thank you for joining us.